Welcome to our next lesson in playing with numbers. We will see some geometric model also here. See how geometric models and how we can represent 9. 3 by 3, like how many dots are there totally? It's 9. There are 3 rows and totally 9 dots. So how we write here? So if you put 3 multiplied by 3, it's 9. 9 dots. Or we can also write this as 3 by 3 square. What do you mean this square means it's representing area generally. Okay. So how we exactly the area is represented? So we take the measurements everywhere as one like that. One, okay, say it's 1 centimeter. So this is 1 centimeter, 1 square. This is 1 square. This is 1 square. So 3 squares this way vertically 3. Here there are totally 9 squares. So what we say, it is 9 square inches or centimeter, whatever it is. 9 square measurement. So now you take it as centimeter. So if this is here, it is centimeter. It is centimeter here. If it is meter here, it's meter. So this, how 9 square we can visualize like this in geometric model. This is 9. So dots will come now. This 1 square represented by 1 dot. So 3 square means representing the area. 3 square is equal to 9. Actually, there are 9 squares in this total. So here, this is called two-dimensional figure. What is meant by two-dimension? Length multiplied by breadth. What about the next one? B choice. Here, length multiplied by breadth multiplied by height is. So here, this is one side. Here, this is one side. So this is vertical side. This is top. So here you got axis like this. This is a 3 dimension, like just like a ball. You got 3 dimensions. So this is called, we put 3 dim like the 3 dimension. Or how would you say, for example, it is 4 by 4 multiplied by 4. So there are 3 dimensions. So what we here write cubic. So we write cubic centimeter or meter or cubic feet, something like that. Cubic meter represents volume. What about the next higher level? What is fourth? When this dice or ball moves, and we get a different picture altogether. So we can say it's fourth. It's just imagine. We can't exactly put it in paper. This two-dimensional only is we can put it in paper. Now third dimension means cubic means just like a ball. We can't. So we require one more dimension. To make a ball, we require height also. The plain paper, we can't make it height, like that. So we are creating a visual effect and making it. So how exactly you make a visual effect like that? See, for example, one square, we draw one more square like this. Now join these edges like this. This is how here. This is behind, You think it's a glass. We can see behind. So this is one side, this is another side, this is back side, this is top, bottom, the other side. So how many, actually for to find out the surface area, how many, you check in this. So you take this is a square, here one, here top one, this side one, this opposite this side, opposite is this bottom, opposite this one, that behind. So So if each side is a square, that's why it is 6a square. We want to find out the area. So each side take it as a square and total how many surfaces are there? You see. And what is the volume? Volume area is 6a square. Square centimeter or whatever it is. What about volume? Suppose this is a, it is a multiplied by a multiplied by a is 4 here. A cube or it is 4 cube. So we write cubic centimeter like that. Cubic meter or cubic feet like that. When we say 4, it is cubic. 4 cube. Okay. Now we will see next some of these natural numbers. So when you say natural number, how natural start school kids how they start with 1, 2, 3, 4. This is only starting. Well, that's why it's called natural number n. So afterwards, people realize, if you go to next big class, you they want the whole number, so they will have added zero also in that. So if you write 0, 1 to 0 means nothing or nil, whatever it is. So next stage is integer. I for Z for integer. So afterwards, to represent minus and plus, like minus 3, minus 2, and then 0 again, plus 1, 2, 3. This is something like you are going 3 miles this way and coming back in the same way 2 kilometers like that. Net effect may be only 1. So we represent first, suppose in the graph to represent, we use the integers. We use both plus and minus. So next, what is a rational number? Next, what about this rational? What is the difference between here? The one side rational number and say irrational. So when they say rational, so all the above numbers are rational only. Suppose including fraction or c, you can write it is 4 by 2. Anything you can express a by b. They are rational. 4 by 2, you can write as 2 also. Or you can say 2 by 1. 2 you can write as 2 by 1. So they are rational numbers. So what is irrational number? So root 2. Root 2 is equal to 1.414. This is a go on like this. This will never end. Root 3. 1.732 dot 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 dot. So what do you mean by root 3? So if you multiply 1.732 by 1.732, you get 3. No, you will not get 3. Exactly. You will get 2.99999. You may get 1, 2, something like this. You multiply and see. Some more numbers are there after this also. You will not exact. It is very nearly equal to 3. You can put nearest to, sorry, this is 3. But exact 3 you will not get. That is why it's called irrational. So you may observe pi is also they are calling irrational. Why? Pi is equal to 22 by 7. It is a by b. 3 point, it is 3.14. These roots will go on like this. This 22.7 is only an approximate value, not exact. For calculation, we take like this. This is only approximate. The 3.14 also, we can take 2 digits approximate to go on. That is why it's called irrational. Pi is a, so if you take exact value of pi, do something like 1.45234, like this will go on like this. Example, I'm telling you. Example. Okay? Go on. It won't end. That's why it's called irrational number. Thank you. So with this, we have just given some introduction to the use of numbers, playing with number, some quiz. We'll continue this in the next lesson.